to start off by talking about Aquatill. And feel free to use one of the podiums if you want, walk around, whatever you'd like.
Very good. Good afternoon, everyone.
Afternoon.
Everyone's still awake from Marion's talk, which is nice. I was kind of hoping that someone slightly more boring would be on before me, but that's the way it goes. So yeah, I'm Day2, a farmer originally and turned precision planting dealer in Australia. That's our main focus now. So we spent a little bit of time here in the States over the last 3 years. We haven't done a lot of that, so it's really nice to be back here. I just got a funny little story before I start. I sat down here and listened to Randy Dowdy and Day2 before, who are almost household names in Australia as well. It's the first time for me, and that was quite exciting. But I sat down there and I thought, man, I'm glad my talk is in one of the small classrooms when we're done this afternoon. And over lunch, just after I ate the chicken, I looked at the session, and then I realised that there was no other concurrent sessions going, so that was pretty exciting. I didn't eat my dessert after that. So, anyway, so mainly what I want to talk to you about is somewhat of a concept that we've got involved in. It probably feeds right into no-till. There's a lot of no-till in Australia, and it probably feeds into it over here. Primarily it's active till, which is basically high pressure jet of water that is, we're using it to cut cotton stalk in half. When I say half, the smaller machine on the left hand side, we're using it to inject floxifur into the cotton to kill it. We don't have the ability to have that deep freeze you have over here and kill the cotton, so we're going to do it some other how. So that's a process that we're working with a lot of our existing customers of cotton growers. And the right hand side, where most of the research started around 10 years ago with Greg Butler, South Australian No-Till Association, founder down there. Greg was interested for his growers, was there a better way to cut residue in front of the implement, basically, so you get a time through or a disc through without any kind of hairpinning. So that's where it started. The long and the short of it is it takes too much horsepower to do multiple rows. So when we're talking 30, 40, 50 rows of water jet cutters, it's too much. So Greg came to me a year and a half ago and asked were we interested in bringing the product to market, and we had a couple of our high-end growers with a lot of precision planting gear, so we serviced them all year round. They were dead keen to get involved, so I guess we're dipping our toe in the water and just seeing if there's a fit. I know there's a fit in Australia for the cotton side of it, but whether there's a fit somewhere else in the world for cutting residue. So I'll run through it fairly quickly because I've probably chewed up 3 or 4 minutes, and there's a couple of videos here and a slide right at the end. There's one of the cotton machine that we use, and it'll make a bit more sense. So this, if you can see, there's a stream of water coming out, not much different to what's coming out of your pressure washer. But that's obviously up in the air. When you drop that down the ground, it's 50,000 PSI, it's quite noisy, but it cuts like a knife and you can't see where it's been. This video may play. What's that all? So this is in just during the testing, and you can see there it's made that cut. You really can't see where it's been at all, but you can go and pull that away regardless of the stubble. It makes a nice clean cut. So that's very loose, dry, probably wheat straw or barley straw that's been cut there. And yeah, it's just for testing. We have it mounted on skids, so there's a nozzle there with a steel pipe run to it and a very tiny orifice. At the end of the slide, you're going to see the pump. We use a pump that's requiring around 200 horsepower, and it's quite large and PDO driven. In the early days, they were running them engine based, so mounting a large engine on on the demonstration machine. This shows it a little bit slower. There's a lot of trial done on basically people wanting to put liquid fertiliser down with this system, so run it in front of disc. There was various ideas. So Greg spent nearly 8 years every year doing something slightly different, trying to give information back to his growers. You can see it makes a nice clean cut, very high pressure. So to give you an idea, cutting steel, they're up around 100,000 PSI, so we're not at the top end, we're just mid-range. It's quite old technology, almost back from the 80s. So proven technology, run for thousands of hours. And yeah, we're just trying to see whether there is room for it in the agricultural industry, I guess. Same thing here, you'll see that skid mounted. So you couldn't quite hear them talk there, but they were saying, you know, about how good a cut it is. And I think if you notice that as it gets down to where it pulls it away there, as it gets wetter, it actually cuts better. So the next couple of slides is going to show cutting capacity. So when basically that graph is showing on the left-hand side zero compaction of the stubble load or the residue load right across to the right-hand side. So on the left-hand side, we've got about 8 tonne of cutting capacity. The tonnage probably doesn't mean a lot, but what we're trying to show here is even when we get across to 40% compression with that ski that we're running through the residue, the cutting capacity goes right up to 16 tonnes, so almost double. So we've got to compress that stubble. Speed's not our enemy, so the left-hand side we've got 4 mile an hour, I guess right across to about 8 mile an hour, I think, on the right-hand side. So the speed doesn't seem to be a factor. The faster we go, the cut is still good, so that's nice that we're not losing any kind of capacity there. This graph just shows the very top line and the bottom line. Bottom line's loose, dry stubble, as if we're running that skid across it. The top one is wet and compressed, so ideal situation, wet and compressed, but we also cut well when dry. So, this just talks about water rates. So water rates off the top of my head, if we had a strip till based machine, 16 cutting heads on a 40-foot machine, 30-inch row spacing, so only 16 cutting heads, we're using about 15 gallons to the acre to cut with. I think that equates to about half a gallon per minute total. So you are carrying a little bit of water, but it's not out of the realms. The machine that we've got at the end has got 2 1,200 litre tanks. Sorry, I haven't got that in gallons, but that's about 250 gallons, I think, 250 gallon tanks on either wing, and then the same on the nose tank. We're using it in sugarcane. Sugarcane guys got a lot of residue they're trying to deal with, so we're testing in that. This one's linseed, so linseed's also extremely prone to hairpinning. So this is all in the earlier days of just seeing can we cut residue with high pressure water. And we should see a video of the cotton machine here. so that gives you an idea. We're just trying to put that chemical into the cotton plant. Cotton's probably not a good fit for where we're at here, but I'm really interested to know, is there anyone that thinks that there's a fit in America for cutting stubble that way or residue? If you need our details, I think you just Google Precision Planting Australia, you'll find us if you think of it in months' time. Thank you.
Thank you.
Thank you, David. We're going to turn it now over to Dave, and he's going to tell us a little bit about Sailing 247.
All right. Well, thank you. Good afternoon, everyone. My name is Dave Krogh. So I'm one of the co-founders of Sailing 24/7. We're based in Ames, Iowa, and it's an honor to be here at what I consider to be the best conference in agriculture. So what I'm going to do is just give you a little bit of overview of our startup company, kind of where our vision and where we're going, and I'll welcome questions at the end. So, you know, as we know, agriculture is the best industry in the world. So why is a company like Sailing 24/7 rocking the boat with this idea of small-scale, lightweight, autonomous farm equipment? So we actually think we can make our industry better. So our focus is really around sustainability. So we think we can have an impact on economic sustainability, so yields. We think we're going to address soil compaction, so we think we can improve soil health, ultimately improving yields. We also think we can lower costs of machinery of crop production, both capital costs and operating costs, and address things like labor availability. So we really think we can impact the economic sustainability of agriculture. Clearly, there's some environmental challenges that we have. We heard about epoxy, or is it hypoxy? Is that what it's called? So there's really these environmental challenges around water quality, and also there's clearly a push towards doing something about greenhouse gases. I think over time we're going to hear more about this concept of carbon intensity of corn production, soybean production, crop production. And we think we can address some of those things with managing fertilizer in a different kind of way. And there's other things that we think we can address too around keeping farmers and operators out of the field and safety and health related things. So we would like to help growers think about farming in a different kind of way. And so our approach is to ultimately get some or all of the big heavy equipment off the field and replace it with smaller, lighter weight equipment. And when you do that, we actually don't want to impact capacity necessarily. So, for example, my family farm has a 24-row John Deere planter. Our concept isn't to tell them to go to a 4-row planter, it's to go to 6 4-row planters. So you don't give up capacity, but you spread out that weight. And if you do that, you really need to go autonomous. And so that's the direction we're going. So we started, we're just a couple years old. We started with a prototype last year. So we started with a planter. It's a 4-row, 30-inch planter. We were on 7 farms this past spring and summer. 6 of those farms were no-till, 1 was not. And we planted soybeans. So we were on 4 farms in Iowa, 2 in Tennessee, and 1 in Kansas. So we got a lot of great feedback. We actually had a few issues, mechanical issues primarily, that we have dealt with, but in general, we were very pleased with our field testing last year. Got a lot of great feedback, and based on that feedback, we're now building a new version for this coming year. So we're building a platform for small, lightweight, autonomous equipment, and at least for now, we're electric powered. And I'll talk a little bit more about that in a minute here. So just real quickly, I'm not going to spend a lot of time on this kind of messy diagram, but our platform is basically has a hardware component and a software component. The hardware component, we have what we call auto light. It's basically an autonomous toolbar on 4 tracks. And that's our power unit. It can attach to different implements. We start with a planter, small planter, but we also want to do post-emerge spraying. We want to do side dress nitrogen this year. Ultimately, we want to actually have a high clearance machine where we can do cover crop seeding prior to harvest and other sorts of kind of post-emerge sorts of activities. Another part of our hardware that is really important to us, we want to keep a low payload weight, and so a docking station is going to be really important for us. So frequent refilling, so that has to be fast and autonomous and reliable, obviously, and so we're working on that. We actually don't have an autonomous docking station in place yet. The other thing that once you get into this, you realize if you have autonomous equipment, you actually have to move it from field to field and place to place. What's the best way to do that? And that's really another advantage that we have, I think, in being smaller. It's a little easier to move these autonomous machines around from field to field. As far as the software side, I'm not going to talk too much about that, other than I'll just say that we think machine learning is going to be very important in our kind of software package that we have. There's a number of things that machine learning, roles that it can play, and I'll touch on that here in a minute. So I did want to make the point that we're not trying to reinvent the wheel where we don't have to. So we actually use a lot of available components and technologies, and